Hi everyone, welcome to the episode number 12. I hope you are making your short notes and you are practicing the question after watching the lectures. So now in this episode, we will be extending the logic of generating combinations. In the episode 11, we saw that how to generate combinations. In this episode, we will generate only those combinations whose summation is equal to the given summation B. Okay. So basically in this question, we are given a number, we are given a sum B, and we have to generate all those combinations whose summation is equal to B. So we already saw that this problem is very much similar to the generating subset problem, right? So we have to generate all those subsets whose summation is equal to B. Okay, so we will follow the same process of generating subsets as we saw in the episode number 7. We were generating subsets and there were 2 raised to the power n number of subsets. But in this episode, we will see that we don't need all of the subsets because different subsets have different summations. We are only bothered about those subsets whose summation is equal to the given summation B. Okay, so we are given number B. Let us say B is equal to 5. And we are also, along with that, we are also given an array from which we have to generate the subset, and let us say the array is having elements 1, 2, 3. So these are the elements which are given to us, and this is B. This 5 is equal to B. This is the summation that we have to generate. Okay, so we have to find all those combinations, all those subsets whose summation is equal to 5. Great. Now, before that, there's a very important thing in this question. If you read the problem statement carefully, by the way, the link to the problem statement is there in the description. You can go and check it out. So in the link, it is mentioned that you can reuse the numbers. So basically, you can use 1 infinite number of times, you can use 2 infinite number of times, and even 3 infinite number of times. So you can reuse the numbers. Okay. All right. So I think you also need the little knowledge of generating duplicate subsets. Right, generating unique subsets out of duplicate numbers which are given to you. This was also covered in the lecture number 10. So if you haven't watched that, make sure that you do. Lecture number 7 and 10 are the prerequisite for the same, and if you have watched the lecture number 11, then it is very good. You will be able to pick this problem up by yourself. Okay, so my aim is to make you ready for any recursion question, any question from recursion and backtracking. So for that, it is very important that you follow lectures systematically. Okay, try to give it some time. Don't try to hurry up things. Don't try to rush upon things. Okay, so just watch the prerequisites, how to generate subsets. By the way, link of all the prerequisites is also there in the description. Generating subsets, then generating unique subsets out of duplicate numbers, then combinations, which is the last episode, episode number 11. Okay, then in this question, we can reuse the numbers, right? We can reuse the numbers, and we have to generate all the combinations whose summation is equal to 5. Now we will start drawing the recursion tree. All right, so let us start drawing the recursion tree. So we are starting with the very first level with our I pointing to 0, iterator I pointing to 0. So we are talking about this particular element. I is equal to 0 here. All right, then we can go in 2 directions. One, we can select this number. Second option, don't select this number. This is how we generate subsets, right? So let us select this number. So if we select this number, we have 1 in our subset. We have 1 in our subset. If we don't select this number, we have nothing in our subset. Okay, but if we are selecting this number, our I is going to remain same. Our I is going to remain 0. Why? Because it is pointing to 1 and we already used 1. So it is possible that in future also we might use 1. Okay. Now you would argue that in future, what if we don't use 1? You should increase I, right? I should have increased I because in future it might be a possibility that I'm not using this 1. But yes, even if I don't increment this I still have an option to not choose that 1 in future. Right? From here, I can either choose or not choose. So I will have that option to ignore it in future. Okay. But there might be a case in which I need this 1 again. So that's why I'm just taking it. I'm not ignoring it as of now. I'm just taking it. Okay. So that's why our I is not going to increment if we are selecting 1 and going to the left side. But if we are not selecting 1 and going to the right side, it is sure, it is definite that you are not going to use this one again. So in this direction, you are not going to use the one again because you are already ignoring it. Okay? If you needed it, if you wanted this one to be there in your subset, you would have picked it up. But because you are ignoring it, you will not need it in future. That's why you are ignoring it right now. Okay? So in this direction, when we are going, our I is going to increment. It will be 1, but here it will be 0. Subset is still empty, but along with that, we should also keep a summation, right? We should also keep the summation till now. We are keeping the subset, that what all elements are there in the subset, but we should also keep the summation, right? Okay, I'm not keeping it. Okay, let us keep it. Let us keep it. The summation is 1, the summation is 0. Let us keep it with yellow color. Okay, I just don't want to hodgepodge things here, so that's why. Now again, for this I have two options. One option is to pick one, other option is to ignore one. So let us say we are picking one. So when we are picking one, our subset will be 1 comma 1. Okay, our summation will be 2, and what will be I will be equal to 0 again, because we picked up 1, and because we picked up 1, we can pick up in future as well. We might pick up in future as well, right? That's why I'm keeping the I same. Okay, again the same argument is here. We might pick up 1 in future, or we might not pick up 1 in future. But for that, like to handle both these possibilities, I should keep I same. I should not increment I. If I increment I will lose 1 forever. I don't want to lose it. Because I picked it up in this step, there are chances that I might choose it in future as well. That's why I'm not leaving 1 as of now. But going in this particular direction, I'm ignoring 1. I'm skipping 1, right? I'm not taking 1. So I will not need it in future as well. Simple. See, if I'm ignoring something now, I don't need it in future. That's why I'm ignoring it. If I want it, I will take it. Okay, if I'm ignoring it, that basically means I don't want it in future as well. That's why I'm going in this direction, and I will increment. I will increment I. It will now become, what will it become? It was 0, it will become 1. So it will remain 1, subset will remain 1, summation will remain 1, I will be equal to 1. Okay. Now talking about this, again there are two chances for this, two options for this. One option to basically, here I is equal to 1, right? So we are talking about this particular element 2, we are talking about this 2. So there are two chances, one to select it, one to ignore it. Let us select this 2. So if we select this 2, our subset was empty, now it will contain 2. And because we are selecting 2, we might need it in future as well. Because we selected 2, there are chances that we select it in future as well. So that's why I'm keeping this I is equal to 1. Okay, summation will now become 2. Here, if we are ignoring this 2, if we are ignoring this, then we don't need it in future. So if we don't need it in future, I will increment I will become 2, and subset will be empty, summation will be 0. Alright, now going further, it's having two options here. One option is to select 1, because I is 0, we are talking about 1 again. I is equal to 0, so we are talking about this 1. So two options, to select it or not to select it. Okay, so let's say we are selecting it, so we have 1 comma 1 comma 1. All right, and our I will still be equal to 0 because we selected 1, and our summation will be equal to 3. Okay, slowly we are approaching towards the summation 5, right? We are approaching toward our answer. Okay, so from this, if we are going to the right side, we are ignoring this one. If we are ignoring it, we should increment I. So I will be equal to 1. Subset, because we are ignoring, subset will remain this 1 comma 1, and summation will remain same 2. Okay, now again this step, in this we have two options again. One option is to ignore. So if we are ignoring this, basically we are talking about I is equal to 1, means we are talking about this 2. So if we are selecting this, first of all let us select it. If we are selecting it, we will have 1 comma 2 in our subset. Our I will be equal to, because we are selecting it, our I will remain same 1. Our summation will be equal to 2 plus 1 3. If we are going to the right side, we are ignoring this 2. So when we are ignoring it, subset will remain 1, summation will remain 1, and I will increment, I will be equal to 2. Okay, talking about this side, so here also two options. One is to select 2, I is equal to 1, so we are basically talking about the element 2. So if we are selecting this, it will become 2 comma 2, I will remain 1, summation will become 4, and if we are skipping this, I will increment, I will become 2, subset will remain 2, summation will also remain 2. Okay, talking about this, one option is to take it on the left side, it is basically to pick this. So if we are picking this up, our subset will become 3, our I will remain same, and our summation will become 3, and if we are ignoring this, our I is going to increment, it will be equal to 3, our subset will be empty, our summation will still be equal to 0. Alright, got it? Now again further expanding it, so here from here we have again two options. One option is to select 1, we are talking about 1, right? I is equal to 0, we are talking about 1, the first element. So it will become 1 comma 1 comma 1 comma 1, summation will become 4, I will still be equal to 0 because we selected it, right? And then if we are not selecting it, if we are ignoring this, it will remain 1 comma 1 comma 1, summation will remain 3, and I will be incremented, I will become equal to 1, right? I will become 1. Okay, now we can see if we extend this recursion tree further, basically this node is going to give us one of the answer, which is 1 comma 1 comma 1 comma 1 comma 1, summation is equal to 5. This will give us one of the answer. Then there are few other nodes which will reach the summation 5. Okay, there are few nodes which are not able to reach the summation 5, just as this one, right? Why is it not able to reach 5? Because I is equal to 3. I already passed all the elements, I already surpassed all the elements. Now no elements are remaining, I is equal to 3. Okay, so it cannot go any further, it is going to stop here. So it is not able to reach the summation 5, the subset is still empty, the summation is still 0. So from here we will stop. Now this will reach 5 in the next step, so in the next step we will stop. Now few of the nodes, so for example, let us consider this one, let us consider this particular node, and let us try to have these two possibilities. One possibility is to select the 2 again, I is equal to 1 means we are talking about this element 2. So one possibility is to pick this 2 again, so it will be 2 comma 2 comma 2, summation will be equal to 6, right? I will be equal to 1 again, but this exceeded 5, this particular thing exceeded 5. Now it is never going to come to 5 again. Why? Because if we go further down from this particular step, from this particular node, if we go further down, we are only going to increase our subset, we are only going to increase our summation. That's why we don't have to go any further down from here as well. So the stopping conditions should be, first of all, when the summation is equal to 5. Sorry, when the summation is equal to the given summation, whatever the given summation is, B, okay, given summation is B, whatever the given summation is, when our sum of subset reaches to that summation, that is one of the stopping conditions. Stop there and move from there. Okay, done. Don't need to go any further down. This is one of the stopping condition. Other stopping condition is when your I exceeds the limit, right? When your I becomes equal to the size of the array, right? Greater than or equal to the size of the array. When your I exceeds the limit, stop. You cannot go any further. Stop it and return from here. Third stopping condition is when your summation exceeds the given summation. As I show in this particular step, our summation was earlier 4, now it is equal to 6, so no, in between this it didn't reach 5. Required was 5, right? Required summation was 5, but in between these two steps we didn't reach 5, we simply reached 6. From 6 we will go to 8, then 10, 12, we will never hit 5 again. We know in future we will never hit 5 because all the elements are positive. If the elements were negative, it might be a possibility that in future some negative element will come and then it will reduce it and make it 5. But here this possibility is not there. All the elements are positive. That's why just stop here. As soon as the summation exceeds 5, stop. Okay. First stopping condition, as soon as you reach the required summation, stop. Second stopping condition, when your I exceeds the limit, stop. Third stopping condition, when your summation exceeds the given summation. When your summation exceeds the required summation, stop. These are the 3 stopping conditions. Other than that, we are going to do exactly in a similar way we did the last question. Okay, we will keep basically finding the subsets, we will keep making those subsets inside a vector, and we will save those subsets inside vector of vector answer, right? But in each recursion call, we will also pass the summation of the subset till now. That what is the summation of the subset till now? We know what is the subset till now, but we don't know what is the summation. We will have to calculate it again and again by looking at the subset array. So that's why we will keep the sum. Okay, things will become much more clear when we start coding this. Okay, so let us go to the coding part. Let us start solving this. All right, so let us again make a void help function. In this function we will pass I. It denotes that which element I am currently standing on. Then we have, obviously we need this vector as well, vector of int arr, I'm sorry, vector of int arr. Then we need the summation b, required summation b. Then the summation till now, this is the summation till now, sum till now. Then we have a vector of int subset. This is the subset which we are generating, subset. Then we will have a vector of int answer. Okay, I will create that later, vector of int answer, because I don't want to use all the space. Or let us just write it, vector int answer. Okay. All right, we need it to store all the subsets, all the correct subsets whose summation is equal to given summation b. First, stopping condition. Shall we start from the stopping condition or shall we start from the recursion? We will go step by step. First of all, we figured out that this problem is recursive in nature. Step number 1 complete. Second step, do the small task. So let us do the small task and then let recursion handle rest of the task. Okay, these steps we learned in the lecture number 6, right? So first step was to verify that this problem is recursive in nature, and it is recursive in nature. It is similar to finding the subsets. All right. Then second step was to do the small task, your small task. What is your small task? You are at the ith element. Either select the ith element or ignore the ith element. This is your small. These are two of your small tasks, right? Okay, these are two small tasks that you have to do. One option is to skip, or okay, let us first skip the ith element. Then second task we will do is to ignore, sorry, not skip, to take the ith element. Okay, first of all, let us do the first small task, skip the ith element. So let us skip the ith element. If we are skipping the ith element, basically we are not adding it into the subset, we are not adding it in the summation, and we have to increment I because we are skipping this element. We should go to the next one, right? Skip the ith element. So first of all, in the subset nothing to be added, in the sum nothing to be added. But if I want to skip it, I should increment I. So I will just ask recursion to do rest of the task. I don't have to do anything, right? I don't have to disturb the subset. I don't have to disturb the summation. I will just ask recursion to do rest of the task. I'm ignoring this element. So I plus 1, comma arr, comma b, comma sum till now. Everything is going to remain same basically because I am not selecting the element. Subset and answer, done. Ignored. This is how I ignore. I don't disturb the subset, I don't disturb the sum till now. Next, if I select the ith element, I should increment the sum till now is going to be incremented plus equal to arr of I. I am adding the ith element into the sum, and I will also add the ith element in the subset. Subset dot push back the ith element. Done. Okay, I selected this element, and then I will ask recursion to do rest of the task, but I will remain same in this case. I is going to remain same because we selected this element and we might need to select this in future as well. So arr b sum till now and subset and answer, done. Selected the number, ask recursion to handle rest of the task. But because I made a disturbance over here, I changed sum, I changed subset. After recursion is done with his task, okay, after recursion is done with its own task, which is at line number 9, then we should undo the changes which we did. We should undo these changes. Okay, just undo this because you changed the sum. Why did you change the sum? Because you wanted to explore this particular branch. You wanted to select this number and explore this particular branch, and recursion did that. And after that, after everything is done, you should undo the changes. Don't leave things in disturbed manner. Okay, this is called backtracking step. I already explained it very well in the previous lectures. This is called backtracking steps. You have to undo these changes. Okay, so arr of minus equal to arr of I, and then subset. I pushed it at the back, right? So I should remove it from the back. Subset dot pop back. Remove the ith element. Okay, this is backtracking. This is a very important step. It is the very important step. You will get the wrong answer if you don't perform this step. Okay, because you will disturb this. Okay, and it is being passed as a reference. So if you disturbed it over here, all the copies of this particular sum and subset will be disturbed because it is reference. Okay, so just do these steps. This is called backtracking. Backtracking is just a fancy name of recursion only, right? We create a disturbance, we ask recursion to handle rest of the task. After recursion is done handling rest of the task, we remove that disturbance. As simple as that. So now we are done with this. Now talking about the base condition, we have already discussed. We are going to have three base conditions. First of all, when the sum till now is exceeding the given sum b, obviously simply return from here. You don't have to do anything. Okay, you are exceeding the limits, return from here. But before that, I should put this: if sum till now, this is the one of the most important condition, right? If it is equal to b, if it is equal to b, save this answer dot push back the subset. Okay, we saved this answer and then we return. All right, and here if we are exceeding the limit b, we will simply return. One base condition was if I is exceeding, if I is greater than equal to arr dot size, then also return from here. Okay, and this. All right, let us now try to test it. First of all, we have to generate this subset, then an integer sum till now, initialize this with 0, then a vector of int answer. Okay, and then call this function help. Calling this function help with I is equal to 0, arr is actually capital here, arr comma b comma sum till now, and subset and answer. Return the answer. Okay, let us try to test it. If there are any bugs, we will try to resolve it then. So sum till now, the spelling is not correct, I guess. Where is sum till now being used? This one, right? Sum till now. And then what else do we have? We are getting a wrong answer. Let me just see if we okay, let us run for this particular test case. We are getting a correct answer over here. Maybe we need the answer to be sorted before returning it, or let me just see how do we need the answer. It should be there in the output format. For each possible test case, print all the possible valid combinations in separate lines. You can print the combinations in any order. Elements in each combination must be non-decreasing. So elements in each combination must be non-decreasing. Then combinations could be shuffled. So inside each combination, elements should be sorted. So that's why we need to sort the given array. Let us sort this. Before calling the help function, let us sort arr dot begin comma arr dot end. We sorted this. We also need to include the header file hash include bits /stdc++ Okay, now let us run this again. I hope, yeah, it is giving us correct answer. Let me submit this. And it got accepted. So You also saw the recursion tree. Now it is your time to take another example. Try to draw the recursion tree. Actually, this is the way to learn recursion. You draw the recursion tree. That's how you understand. Before that, you already know how to use recursion. When you want to deep dive into understanding of recursion, how is it working, you need to draw that recursion tree. Okay, so it is your homework that you draw the recursion tree. One more homework that I want to give you is try out the combination sum 2. Link will be there in the description. I will provide it. Combination sum 2. Okay, in the next episode we will try to solve the combination sum 2 problem. All right, so take care and try to find out, try to comment the space and time complexity in the comment section as well. In the worst case, what will be the space complexity, what will be the time complexity. I hope you are better aware of this by now, right? We already saw this in the previous episode. It is much similar to that. Okay, let us meet in the next episode. Bye bye, take care.